Hello folks, my fellow mathletes, welcome back to question number 24. Let x be the three-digit number with digits A, B, C, and y be the three-digit number with digits C, B, A. The digits A and C are not 0, otherwise these technically wouldn't be three-digit numbers. If x minus y is 495, how many possibilities are there for x? So there's 50, 40, 24, 36, 32. Okay. Most of these, interestingly enough, I'm noticing are multiples of 4, but that's really the only thing I'm noticing. 50 doesn't fit that pattern, but maybe 50 is the answer for reasons that I don't quite know yet. Okay. So with questions like these, where they give you the digits written out as A, B, C, A, B, C, D, that sort of stuff, an important thing to remember is how our decimal system of counting and representing numbers works. So let's just briefly talk about that, and then we'll dive into the question. Hopefully you know all this, but if you don't, it's worth noting. So when I write down the number 236, what I'm really saying is 2 times 100 plus 3 times 10 plus 6. Technically times 1, although we don't often write that. Okay. Another way to say that, 2 times 10 to the 2 plus 3 times 10 to the 1 plus 6 times 10 to the 0. This is what we mean when we write out our numbers. So if I were to write out, x is A, B, C, I could write it as 100 times whatever the single digit A is, plus 10 times whatever the single digit B is, plus C. And y is CBA, so it's 100C plus 10B plus A. Now, what did they tell us in the question? In the question, they said x minus y is 495. Great. Now we have an equation we can use. Okay? And we have, 100A plus 10B. The 10B's are actually going to cancel each other out. So let's take a look at that. So x minus y is 495. So that means 100A plus 10B plus C minus 100C minus the 10B minus A is equal to 495. Well, we can clean up the right-hand side here, the left-hand side. Those guys cancel. We can collect like terms with the C's, or we can collect like terms with the A's. I'm going to collect the C's together and the A's together. So 100A minus A, that's going to be 100A minus 1, 99A. And then we'll have minus 99C when we clean this whole thing up, is equal to 495. I notice I can get 99A minus C if I clean it up a little bit more. And I'm willing to bet that we can divide by 99 on both sides. At least I hope so. 495 divided by 99. Just grabbed my calculator out. It looks like we get an answer of 5. So A minus C has got to be equal to 5. And I think that's really the only condition we need. The B's cancel out, so I think B can be whatever we want. B can be anything, so B could be 0, 1, 2. We have 10 choices for B. So now I'm thinking that, I made the offhand remark at the start, most of these answers are multiples of 4. But it looks like we want multiples of 10. Because anytime we have a pair A and C that satisfy A minus C equals 5, so maybe 6 and 1. Then we'd have 6, 1, and B could be 0. 6, 1, and B could be 1. 6, 1, and B could be 2. The 10 choices for B, no matter what our A and C are. So we need to figure out how many pairs AC work here, and then multiply that by 10. So actually, I think what we've done, if we go back to the original thing, We've narrowed it down to we just need multiples of 10 here. So I think the answer will either be 50 or 40, depending on how many pairs AC can we get. So that's kind of nifty. So AC, we need to have A minus C equal to 5. So we could have, well, we can't have 5, 0, because C can't be 0. So this one's right out. We could have 6, 1. We could have 7, 2. 7 minus 2 is 5. 8, 3. 9, 4. And the next one we'd want would be 10, 5. But, of course, 10 is not a digit. A's got to be a single digit. So there's 4 pairs AC, 10 choices for B, and that's going to give us 40 in total. Four choices for AC, and for each one of those we can assign any of the 10 choices for B, and that gives us a final answer of 40 possible pairs X and Y, and each of those will give us a different X depending on what our A, B, and C are. So $40 possible values of X, and that was what we were asked for, correct? How many possibilities are there for X? Looks like we got them all. We could probably, if we wanted to, take time to list them all out, but really there's no point in doing that other than to verify for ourselves that we really do get 40. And then we'd have to think a bit more as to why we can't get more, but no point in doing that. Save yourself the time because we're going to be looking at question number 25 in the next video. Hopefully you've been enjoying this Gauss paper, and if you have, feel free to like or subscribe or share, whatever you want to do, so that more people can take a look at these sorts of contests. No matter what you do, still, thank you for watching, and I'll see you guys for question number 25.